angle relationships in triangles. Today we're going to find the measures of interior and exterior angles of triangles, and we're going to apply theorems about the interior and exterior angles of the triangles. So first of all, a few vocabulary terms. An auxiliary line is a line that needs to be added to a figure to aid in a proof, and I'll show you an example of that in a few minutes. A corollary is a theorem whose proof follows directly from another theorem. And these vocabulary terms, I drew a picture to help us out. The interior of this triangle here is all points inside a figure. So in our example here, everything here would be interior, all the way going to all the points on the interior of the triangle. The exterior is all points outside a figure. So the outside points would be everything else. So it would be all of this stuff out here. Everything else outside the triangle. Okay? So the interior angles, you can probably guess, would be the ones on the inside of the figure, which would be in this case angle 1, angle 2, and angle 3. The exterior angle is the one that's on the outside of the triangle, and in this case that would be angle 4. Now the remote interior angles are all of the angles that are on the interior and are not adjacent to the exterior angle you're talking about. So all angles that are interior and are non-adjacent to your exterior angle. So in this case, angles 1 and angle 2 are remote interior angles to angle 4. So 1 and 2 are my remote interior angles to my exterior angle 4. Okay? So that's a few vocab terms. Now we have some theorems. First of all, the triangle sum theorem, which says that the sum of the measures in a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. They all add up to 180. And there's a beautiful proof of the triangle sum theorem in your book on page 223. And it takes into account using the auxiliary line that I mentioned earlier. So let me show you this proof really quick. It's on page 223, and you'll see that what they do is they have to, here's my figure, and in order to prove it, they have to show this line L here and create angles 4 and 5 to help prove this triangle. So as you can see, angle 1 and angle 4 are alternate interior angles. If this line L is parallel to line AC, then 1 and 4 are equal because they're alternate interior. And for the same reason, 3 and 5 are also equal because they're also alternate interior. So as you can see here, we have line L and we have three angles, angle 4, angle 2, and angle 5, that add up to 180. And because 4 is equal to 1, and also 5 is equal to 3, then 1, 2, and 3 also add up to 180 degrees. So this is a great proof of the triangle sum theorem that uses this auxiliary line here to help prove that, that theorem. Okay, so that's our triangle sum theorem. Now, I talked about corollaries. A corollary is one that is very, very similar to another theorem, and it follows directly from that other theorem. So there's two corollaries from the triangle sum theorem, and one is that acute angles in a right triangle are complementary. And so here's an example. So if I have a right triangle, then notice that I have everything adds up to 180. And if I take away, so 180 minus 90 equals 90 degrees. So that means that these two angles have to add up to 90 degrees, which means that they are complementary. So if we labeled this F, D, and E, we could say that angle D and angle E are complementary, which means that they add up to 90 degrees, okay? And the other corollary that comes directly from the triangle sum theorem is this one here. The measure of each angle in an equiangular triangle is 60 degrees. So you can see that if we draw a triangle that's equiangular, then all of them are the same. So we'd have to take 180 and divide it by 3, which gives us 60. So that's why all these angles are exactly 60 degrees. So anytime you have an equiangular triangle, you know that the angles are all 60 degrees. So the measure of angle A equals the measure of angle B equals the measure of angle C, which equals 60 degrees. Okay? All right, the exterior angle theorem is the measure of an exterior angle is equal to the sum of its remote interior angles. So these two here add together to equal the exterior. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Okay, we'll do an example of that in just a minute. And the last theorem of this section is the third angles theorem, which is here. And that says that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent to each other. So for example, if I'm told that L is congruent to R and N is congruent to T, then I know that angle M is congruent to angle S. Okay? All right, let's do some examples first of all. So we'll start off with an example of a triangle sum theorem here, and then we'll do an exterior angle theorem example, and then we'll do a third angles theorem example. So here are some examples for you. So first of all, the triangle sum theorem. Here we have a triangle, and we have three different angles here that all have y in them. And I need to find out what the measure of angle D and the measure of angle A and the measure of angle V are. So what we know then, based on the triangle sum theorem, is that they add up to 180. So I can say the measure of angle A plus the measure of angle D plus the measure of angle V equals 180 degrees. So if I was to plug in what I know then, A would be here, 2y plus 2. So 2y plus 2 plus D is 3y plus 13 plus V is 5y minus 5 equals 180. So if I solved for y on this, I would get 8, 9, 10y equals, we have 15 minus 5, oops, sorry, not equals, minus, so my plus 10 equals 180. And then subtract 10 on both sides, so I'd get 170 divided by 10, so y equals 17. So now I just need to plug in 17 into my three different angles here, and I would get, I've already done this problem, hold on, I would get that I have 36 degrees if I plug it in, 80 degrees, and 64 degrees after I plug in the angle, or y equals 17 into the 3. Now a way to double check this is to see, does 36 plus 80 plus 64 equal 180? And yes, indeed it does, so we did it right. Okay, the exterior angles theorem here says that the measure of angle K plus the measure of angle L equals the measure of angle LJH. These two remote interior angles add to equal the exterior angle here. So if we plug in what we know, the measure of angle K is 7x, plus the measure of angle L is 6x minus 1, equals the measure of angle LJK is 90 degrees. Okay, so we're going to get 13x equals 91, x equals 7. So then if I plug it back in, to find out what the measure of angle L is, for example, I plug it in. 7 times 6 and then minus 1 is 41 degrees. Okay? This last one is the third angles theorem, which says that if you have two angles here, which are congruent to two angles in another triangle, then their third angles are also equal. So the measure of angle U equals the measure of angle S. So U is 5x minus 11, and S is 4x plus 9. So x equals 20. And then you plug it in, so the measure of angle U would be 20 times 5, which is 100, minus 11 is 89 degrees. And I could also find the measure of angle S by doing the same thing, plugging it in there. And it should also be 89 degrees. Okay, so those are some examples of using these three different theorems that you learned today.